of Windows OS installed in the applications. Software can be anything, and there will be a time kernel, whatever do that, and it takes care of in the IO devices that real world, or light bus or what. It can control the PLC or some numeric control or CNC. So that showing how it. So when you use system dedicated for C is used, it if you take a motion control at a certain, and if you want a, it is basically designed and it also fixed task cycle time. But when it comes to allocate it in a real-time mode or control highest priority, so that what, and the normal PL can maximum, and so you can allocate it. But the motion task has microsecond, that is means that is it, and you can segregate it. The slot okay through the field devices, what you are seeing in the down, so you can see some IOs, slave IOs, some motion control, and some oversampling modules. I will explain about what's oversampling in the coming slides. Okay, so now yes, now the question has to come, because C is mainly for real time. It will not do it. Comes to PLC, the question will be, okay, so here, so what is real time is nothing but to happen within, and it should, it means there's cycle time. So in this example you can see, so there is a base time. So here 20% for a real-time task and 20% for Windows. So the can be of considered as, and when it comes to real time, see the actual here, the EtherCAT or any real-time software percent of PC's power and Windows operation, any other Windows operation consuming. So this is the way the divided between the real-time device and for the non-real-time Windows task. Okay, so so here it is the motion control part also, and the green one, or the HMI task, and then the PLC task with blue and the orange colors. So this is something you can this is just how this idea to make a PC as a real time. For example, a human is can what efficiency, but 100% if just using our brain's power. Him and he, wherein using the of the PC. Advantages while using, so we can use not a dedicated, can understand it. Everyone what's and any tool like C or see you can use this and motion control. Yeah, there are some available for. You can also integration is very generic and industry and connectivity through as I using field bus, you avoiding the parallel wiring. Okay, so into servo X. Okay, when you come up do a lot, you the in making a mechanical, and it's easy. Okay, so he servo axis with point. So you can camming profile of your own, do flying saw, so mechanical camming, and you correlate with the soft axis. So and if you are having a workbench with, you can go for and it 66025 stand. You can do the coder and it's adaptable. So and see also possible. You can make your own with the soft PLC concept. Okay. Robotics not cover completely. It is also possible. You can do your kind of transformation. Reason became electron and the mechanical gearing. For example, if you and the other should follow. So prepare in mechanical, you can make bring into axis master and the slave by ratio. So here you can see the IPC here soft SPS layer, soft PLC, German word for PLC. So you the engine for absolute or has to act from the engineering to the soft motion layer. So that means the PID control. So whatever you have to go do since servo the PID it has to do the position looping or velocity looping or like a torque control. So whatever it is, it has to take care. So all the command will be fed to this layer, to the software. It talks to the field bus device. Can be of anything. So either one or you from Siemens or Sarcos can communicate. Okay. I added a to show industries. So here I took example of film industry to see. Maybe I can show here. Okay, maybe I'll yeah. Is I personally robo for robo. So the sequence in Fast and they integrated some IPC, and they did so I did just I thought of okay. So let's remote field bus technology. So there are more than many interaction of what's start with or maybe yeah, RS-23, which was from the old instead of RS-2 to any device, peer-to-peer communication. One can send thing will happen. 485 came, so communication, and you can communicate a number of slaves. So this way, the company start a device for their course came was from Siemens IP, but here we will see about latest, and it's field bus communication. Yeah, so I would like to so what? So EtherCAT is the Ethernet field bus. So converted communication. It's real time of real time slides. Okay, so using no underlying subsystem, no need of usually the means it convert some field bus, so convert it to EtherCAT. There is no further, and you can get the data. Is the any slave, whatever. So it is very good in see all the data in the master and thing. So it's easy to log. Okay, so because as of now, as our Ethernet with 100, so same speed it maintains full duplex megabits per second. So for example, of 1,000 discrete of 100 nodes in, so it is, I think it's not possible. You can in 100 microseconds. So that's it. So it is it has lot of advantages, and I think the time is limited. and I will just means EtherCAT. Cat is nothing but for example, just concentrate on this. So I will explain how EtherCAT works. Imagine a train, and it never frame in Ethernet. Explain is very famous. So in Ethernet, it is like a technology. When a client initiates, the data will go comes back to the client. Client should has to get the data. Very good for network, but will it means no, because for field bus it has to be here. It is real time. Imagine this is moving on Ethernet. The frames are moving. Consider it as a train never stops. It's just see that means like for every wave there will be a certain image will be data of the process image on the fly with the station. So in every slave, so when some passengers and goes into the train, the same way. So when that is station information and get okay. EtherCAT is serial communication. So the master, that's the IPC, has EtherCAT master, and it through Ethernet medium. The blue arrows are like the to every slave. So so it goes in the same medium. So this is a decentralized IOs communication, and there and a diagnostic feature, because slave will be with one. Of course, Ethernet normal Ethernet wire, and you can. So advantages in topology, it is very bigger. You can do topology, star topology, and to 6 ultimately unlimited. This is the limitation of, and as they communicated late back of the German means this is it needed. They practically they communicate 40,000 and add on more slaves. The Ether and the network expansion can be means new switches, and kilometer is not. Yeah, that's it. Thing what I fly also connect and if you remove, see my cursor in the fourth slave. So with the slave, and I have, okay, and then I Synchronization to the slave device, and just automatically works. That means the master or the slave. The limitation with any and EtherCAT and what next is the EtherCAT G. That's yet to come. Okay, so here technology. So just I kept just you can see the video. I will so you can see the medium, the frame passes through the medium. So what's the what it is moving is the frame. It is passing through a medium, that is Ethernet, and it is passing every slave, that is every station. So it will update the station, every station's working counter, that is slaves working counter, whether it is operational or not operational. You can see in the slow motion thing. So it is giving data to a station, and it is taking some data from that station. So how we can compare is when a frame moves into a slave, it has to take some data from that slave. For example, the input status. Again, we can take example of a manifold. So it has to see whether the it's happened, and it has to take the data from the sensor, whether it is open or closed. So that's the input data. So and based on that, the red packets what you saw here in the video, so it has to actuate something. So it has to actuate the valve to open or close. This is how. Yeah, and just I will quickly yeah, as I said, Ethernet, and it can interface field bus devices. You use it as a converter, and you can use a Profinet, anything. You can connect with the decentralized serial interfaces. Gateway. So every company is having some gateway to convert the protocol to a different protocol. So, EtherCAT follows this IEC specific open for everyone. Okay, so EtherCAT is the largest. The many so more than 500 already signed EtherCAT. There is a separate EtherCAT Technology group, which is in Germany. And for example, if KSR, some department like Mechatronics department want to develop their own slave, they can approach EtherCAT Technology group, and they can make their own and devices with a master. Okay. So so other advantages of EtherCAT is like other field bus, like every field bus can communicate with the slave, and slave to slave not always possible in many field buses, but in EtherCAT, as you saw, a frame will pass through a slave, and it moves. It will be continual master. That is also possible, and also you can do master to master communication. Yeah, this is Okay, so EtherCAT is used all over the world. I think except Siemens and maybe most of so many industries. You can see some applications in packaging, high-speed process, injection machines, other test beds, robotics. So also you can use in appreciation. Infrastructure is not you can connect to any small. Yeah. Okay. So EtherCAT, which is trending field bus, and just I would like to add something called extreme fast control. So this is still more needed. Explain what's XFC. XFC is nothing but extreme fast control. So for example, till now we a slave device means of some protocol like EtherCAT, and a master have a control over it. For example, you can take example of some pharmaceutical industries. So where the tablet counting or because it's very small and you need to do it in very fast, means you can. So this is possible with. So also if you use EtherCAT also, the outputs cannot be synchronized. Travels from a slave to the other slave. So for example, when a frame travels to slave number, triggers some output, and slave number 10, it triggers more jitter in that, eliminate, and needs time stamping. So all this happens using extreme fast control. There is a video for that. How it happens, but you can see the system performance. The cycle time can be minimum 50 microseconds. The IO and so we are going to see distributed clock technology. I think if you have worked on this, you might have come across this distributed clocks. So the same technology is adapted here, and so oversampling is a technology means there should be some intelligence in the slave. Rather, the master is having the intelligence, and it gives and takes the data from the slave, and it will not and it will take decision. If you consider the PLC is running at 1 millisecond task time and it is getting the data, it is quite not enough. In that 1 millisecond, lot many things can happen. As I said, in tablet counting machine, so number of tablets can fall in 1 millisecond. So many things. So in those situations, you need oversampling. So what happened in that 1 millisecond? So those things is possible with time stamping. Using this XFC technology means there is a added intelligence in every slave that collects the data, and it gives with the time, and it. Here you can see this video. So here what you see is the see, and this application be on the same time, it is synchronized. So this is the application. So you can see in a normal. So in the slave number 1, it can trigger some, and it goes immediately. And when it comes to slave number 10, it will be a small jitter. So the EtherCAT EtherCAT is faster. So even the microsecond is not this thing, there is a local clock which manages it. So in normal operation, but when you are using modules with more intelligence, that is with the distributed clock technology, for a, so you can see in this video slave. So for example, the means they have the intelligence. So we have to using this reference, it has to synchronize all at the same time. Somebody's okay. So here you carefully see this, the clock. The clocks are different now, the DC clocks, and here in the next frame, so we assign one as a reference clock, and in the movement of this reference clock, so all the clocks has to be synchronized for the same time through the frame movement. So synchronization is successful. Now that's the red packet with the distributed clock time, and you can see there in the intelligent module, but it executes at the same. So this is how extreme fast control technology, it is very useful and like technology like pharma industries. So the deviation between the clocks in the different slaves is less than 1 microsecond. So same as in you can also connect 65 IOs, slave IOs, and there is no limitation. So before we have a question, I think so can I borrow?
Yes, sir.
Okay, thank you. So just quickly we will wrap up the power of what's IPC, what's soft PLC, what are the remote IOs, that means the field bus, and so we saw about the motion control like robotics or some interpreted access. There is a technology to do, but the he can program. So as I already he using the conventional PLC logics by following this IEC 61131 standard or anything, how he gives it. He can do in C++ is so because 31 object, so it helps in re code what you develop. So this is, and when for example a person from he's PLC, what is motion control, nothing, but still he can do his logic using C++ and he can integrate it. So that is also possible. Or he can divide the work from a PLC engineer. He can do plus and the real-time so this is also possible. Okay. Also, he can interface to MATLAB and Simulink, and he can. So here you can see MATLAB. You can understand this. Talk to and it can handle, and you can do also means direct talk to the hardware like the EtherCAT sleeves. Okay, so now we have the solution for different areas like scientific automation, some industries, windmills, power generation, so many things. So all this is possible with PC-based control. With PC-based control, but I would video so which is based control. This application particularly interfaces. Just you can. So what you can see is a mercury ball. This is not an animation. It is real. This system is installed in Singapore. I never been to Singapore. Maybe if you get a chance to go to Singapore, if you are already there, means you can see this structure in Terminal 1 in the Changi Airport. So this is a mercury ball. So the mercury ball, each ball is like a axis, and it is connected through a wire to a servo axis to a shaft, and they are just simulating a kinetic range. If you see which is connected to EtherCAT, means which is integrated with the EtherCAT field bus technology, and I think there are several master devices used, and they are interfaced each other. So I think so many companies like Germany from German companies, Beckhoff, Siemens, all together put together, and they did this structure. If you can visit Singapore, you can see this. So this is all from my end for the PC-based control, and what's field bus, what's motion control. The last video, what you saw is example of integrating PC-based control in the means for the automation for the real-world applications. So now let's talk about Industry 4.0. So what I would say is, so this automation industry evolved many years, I think from 1970 to 2020, and even I got chance to work in several projects, and it means I have a good hands-on experience with that. But later on, in my present company, my manager told, okay, Gopal, you did this many projects, and now we have to transform to Industry 4.0. So at that time, when he explained what is Industry 4.0, it was like a nightmare. So I just took the slide from him, and just I'm presenting it. So here you can see industry as industry with E. So it is also a German word. So just I borrowed from him. So how he explained is what is Industry 4.0. So from the beginning till the end, everything should be connected. So here he just demonstrated with this. So connection of products, production means and equipment along the entire production and value added chain, means from barcode to ERP, whatever, everything should be connected. Means data, also analytics. How he explained, and definitely I didn't. Then so we to realize Industry 4.0 in our factory. So we need to secure horizontal and vertical communication. Those communications should be secured. That is important. And we should have a consistent and integrated engineering over the entire product life cycle. And we should have central cyber physical data acquisition, analysis, and evaluation. Because analysis is very important, because just collecting the data, you cannot do anything. You have to analyze it, and you have to do the evaluation, and you have to act accordingly. Okay. So human operators at the central point of control in a network production, and control application based on some open automation and IT standards. So there's a lot in this. So we will just go into it one by one. So in this example, he just demonstrated the smart factory. So you consider a factory. It is having a lot, means in the machine shop, or you have a lot, and if you see one by one, it's a kind of machine, or you can just imagine an assembly line with each machine is individual, and it so whatever we just we see IO or sensors and actuators, what all integrated into this machine, and this is how the machine is working. So individually, it is not talking to each other. And then, so to realize Industry 4.0, what we have to do? We have to do some traceability. So first, the machine and machine should talk. So using some horizontal communication to be centralized to some different IPC. So that's what you can see here. And it has to go to a database server. It has to connect to the cloud, and the cloud to the smart factory systems. Okay, so it can be secured from top to down. So we or areas, any kind of communication to talk to the cloud. You can see from the top, from the cloud to the database, and you can use again OPC or, and for the machine to machine communication, centralized common, either OPC UA, because it's more generic, and it is use EtherCAT automation protocol or ADS, or several other. Also, you have to realize the machine from a controller. It has to integrate to the IOs. So through any field bus like EtherCAT Profibus or Profinet, whatever. And yes, so this is so this is how you have to also realize entire product life cycle. So yeah, using PC based control, we can do this. Based control, you can do such engineering, but PC based control is preferable. Okay, so central nothing but you have to take note on this cyber physical system. So what it is? Autonomously, it has to give the data to the cloud, the neighboring machines, which are called cyber physical system. Okay, and for analysis, there's a lot of tools available in scientific automation, or there are a lot of consultants for analytics, and open automation and IT standards. Fine. So this is how he explained me, and I was not very clear how he explained, because he said in our factory can be easily implemented, and this gives us efficiency, and so the product walks to the market, and so this is so what's industry for already adopted it. Then I came up which may not different domain,
but yeah, different.
So called connected call. This I think this is done Jitsu. Okay, so what is connected? Different topic, just for we studied before, and just so in Japan, and because dairy he was unable to this manpower, and get up every day at 4 o'clock, and he has to do milking and activities. So this means to an engineer in Fujitsu, this farmer, and then they started researching on it. They came up with this. So they connect pedometer to every cow. So you, and they are collecting data from the pedometer, and they are doing some analysis. So just for very important. Okay, so what he needs actually, what the farmer increase the milk production. They are also having some fixed, and they have to move on. Of course, there are other problems in this. Cows can easily get into some health issues, and there will be a loss. So he has to do some maintenance for that, and also he has to improve his production, milk production. So so these two things they kept in mind, and they started digging on something. So how he can increase his production? So so production happens. For example, he has to increase the number of cows in his farmland. After this white revolution, they were using this artificial insemination to the cow, and they were achieving 70% consumption rate, and they were producing more number of cows, and of course then the milk. So this is the concept, but to see means because to do artificial insemination, a farmer should observe a cow, and when it is ready for reproduction, means manually he has to monitor every time, and based on that he has to do this artificial insemination. But because whatever his observation is manual, maybe he can do, or the workers can do, but it will not be correct all the time, because it's human. We cannot observe that properly. So the pregnancy rate of the cow is just 39%. He has to improve this. So what the problem with this is he cannot observe every day in the night, because as I said, he has to get up for feeding or milking from morning and till night. And this cow will be in heat, means that is stress only in the night maximum, means it's not only, but it's maximum in the night from means every 21 days. It is like consider 10 p.m. to 8 a.m. in the night. Okay, so he cannot see monitor that, because means all the day. Then again he has to. So and now let's go to. So why the solution with pedometer? Because the pedometer, the steps the cow takes. So like humans, whether steps will take 10,000 steps per day, that's out of our topic. But how they connected, you just focus on this. So every cow is having a pedometer, and it goes to a dipole antenna, and it is received to a router, and it goes to the network, and goes to cloud. So they for the analysis. Information about or office. Okay, this based on the step, we can understand the cow is in some problem or health issues, or cow is ready for reproduction, and he can artificial insemination. So all the steps Fujitsu can come up with some product. So you can see the green line is something like, and the orange one is like it takes more steps when it is ready for reproduction. Peaks up, it really goes down. So and then he has do this so this is intelligence and the artificial insemination. Okay, in the pedometer, and the data is cloud, and the start. So what he can do in the next 16 hours, he can do this he can produce it. And also the good thing with this is 16 hours later, if he can do this, he can probably get a mail, and if it is little early, he can whether decide whether he wants a female, means like for further milking. So maybe he can decide, he is having a chance to decide whether a female or male, and also based on the steps he can realize whether the cow is in a problem, means that is for the maintenance, everything. So this is very simple, but it is very good example for industry 4.0, but not in the industrial domain, but in the different domain, but still. Okay, so I got this concept and I understood everything. So the very next day I went to my manager, and just we started digging more about what's smart manufacturing in India, at least in our factory. So again, so just compare the revolution what I show in the very first slide and to this one. So if you see, the first revolution started from England through mechanical automation, and then second revolution by the US through industrialization using mechanical automation, and then the third revolution with the invention of PLCs and electronics, so many things in the early 1970s. And now we are going to talk, means the hot topic is smart automation, that is Internet of Things and the Industry 4.0. So what's smart manufacturing? Means there was an analysis made by McKinsey. Just that India's manufacturing sector will grow six times more, sixfold by 2025 in just 5 years. That is up to $1 trillion. Every Indian company, everyone should get potential for line before has to be used to improve process, and we can go and in, okay. So our so what example of some order processing with packaging. So just with some raw material, just we are giving some input and we are getting some output. You can imagine whatever the industry you are into. But in every stage of manufacturing, there is a data. For example, before be some data like the inventory, and during the manufacturing process, there should be some. And for every stage of manufacturing, there are some data. So how to operate, how to assemble it. So there is a huge collection of data, and with this data, can we do can we do our manufacturing efficiently? Means no. So the data and analyzation should be mixed up. So you have to collect the data and you have to analyze it. So for analyzation, there are a lot of tools available. Last slides. So next we can see how the data can be converted into knowledge. Fine. So smart manufacturing is just it deals with the data, means acquisition of the process data, analyzing the data, converting it, and better decision making. So you can do predictive maintenance or whatever. Okay. So when it comes to end user, means we are just supplying to an end user. So what is his expectation? So every end user, whether you see locally or everywhere, so what's their expectation? Means they have to have better sales, flexibility, efficiency, more profit, more market share, brand value, everything. And what they do not want is like energy consumption. Means they want to do everything with some less budget and fast time to the market. And they have to reduce the labor cost, because the manpower is another headache. So all this means all this should decrease. So I think both is possible with the smart manufacturing. That's using okay. Now just I quickly means wrap up what's Internet of Things. Applying the Internet of Things and services into the manufacturing environment would bring efficiency in operations. So this is 4.0, and this involves the cyber physical system. So this, as I explained, smart machines and production facilities capable of autonomously exchanging information, triggering actions, and controlling each other independently without any manual interruption. So that is cyber physical system. So the smart factories with smart products. So they are uniquely identifiable, know their history, because we better have the data and we can go back and right. So status and the alternate routes to achieve that target. Internet of Things, IoT is a revolution that is technological extension of the past industrial revolutions, right? So the technology is connectivity, and real-time data sharing ability, and adaptability, and fine. So with Industry 4.0, so what you can do is you can assets, time response, and you can increase anything. So to make in a summary, to make it more efficient, more flexible and responsive, more sustainable. So how enable means is the cyber getting more process data from the shop floor, ensuring connectivity, and so so this competitiveness and high also for a company it's a investment. Okay, so now just we finished with data collection and analysis. And so how you can analyze your data? I mean, there are so many tools available with several the machines can collect the data. You can do local analyzation, and it can give the data to the cloud. And this can be further taken to some other analytics server. Like so, here I took example of EtherCAT server from Beckhoff, but Amazon, from Microsoft, so many. So also you can give this to a third-party analyst. Yeah, machine one, it can have yellow, give the data to yellow every machine in the, and this will go so do this analytics, and also the same from the machine builder and also from the third-party analyst. Data in hand, and you can do what are we can get like electricity resource used machines, like because component in a machine cycles, or you have to based on that you can act. You can increase the operating. Yeah, so as prediction and decision using real-time data what we got. Finally, to summarize, so just take a look on this. This is very important because we gone through two topics: automation and Industry 4.0, means like smart manufacturing. So in this picture shows everything. So you can see, so there are field bus devices, means the real-time IOs, and it is connected to a device that is the PLC controller or an IPC, and it is having a certain engineering or through PLC, C++ or something, and it talks to the runtime and the data transport, that is like the bro. So it's like OPC or brokers are available like MQT something, and to the cloud. And so through cloud there are many analytics servers available, like here we have an example of Microsoft Azure or Amazon AWS. So this is the complete architecture what we gone through. And yeah, so before I complete, so Industry 4.0 is very relevant for India, because now automation is directly connected to the IT world. So India is good in IT. So India is an IT hub. It's more, and huge number of software engineers are available in India. And to achieve this within 2025, so that's means we need a lot of engineers in this segment. And so if you go to any other country, so always they say Indians are good in mathematics and technology. So I think we can use it. So with Industry 4.0 and other. So that's it from mine. Thank you very much. So if you have any questions, you can shoot up.
Participants, if you have any questions to the resource person, you can unmute yourself and you can ask the questions to our resource person. I request the participants to unmute.
Hello, sir.
Yeah.
Sir, good afternoon.
Good afternoon.
Thank you for this informative session. One thing I would like for us in industry in India.
To say it. So every just I came across several on the traceability and to the what is complete. If you see many industries go to Chennai, there are a lot of automotive industries. All were called traceability. Something very important because while selling a product, so likes to know from the data of who assembled it. You can get from the barcode. End user needs, so he can go back. So this good stage in every company with the traceability. 4.0 we have a lot. The upcoming engine, and they can bring it. We can achieve the complete.
That means
we are more engineers with the and so thank you. And anybody?
Any? I request to unmute yourself to post your queries.
sir, to realize the benefits.
We work means I think
okay.
So as soon I think we can. I think they can adapt it within next.
Okay.
So all are working for it.
Thank you very much.
Thank you.
Hello, good afternoon, sir. I am Thiruvengadam.
Good afternoon.
Sir, very informative message. As I am, you are our student of KS. We very proud to that to get for this function. We get a lot of information from the current scenario about Industry 4.0 and recent trends in automations. Very informative, sir. Thank you so much.
And also thank you very much for giving this opportunity, Rajsekhar sir.
Yes, sir. He will come, sir.
Yeah.
One second.
Yeah. Okay. And if you have some questions, you can write me a mail also, or you can contact Raj, and I can revert to you.
Okay, now MOC can proceed.
Sir, Dr. T. Rajshekharan sir, K.S.Rangasamy to give the conclusion.
Afternoon to Ananda. It's say about global. It did he did about and he important things like real-time problems he mentioned many topics like TwinCAT, EtherCAT, Ethernet, and we are waiting for that also EtherCAT G. And he may know about backup automation softwares. And he mentioned many things in and smart manufacturing and smart companies, smart factories, and machine to machine protocols. So he touched all the. I am really very proud. As like the objective he had, of working experience and having a great ability to give this lecture. I'm really very proud. Is our college to say this type of lecture today. I'm once again and thank you for this great lecture. Thank you, Baba.
Thank you everyone for a lot.
Thank you, Prabhu. Gopalakrishnan sir. Announcement. Participants and stay with us. Feedback link Instagram. So I request either in WhatsApp or Instagram to get the feedback as well as the meeting link. Please. The form will be kept open only for 1 hour from now. I repeat, will be shared in WhatsApp and Instagram. So I request all the participants to join either in WhatsApp or Instagram, Telegram to get the feedback for getting e-certificate only for 1 hour from now.
Thank you so much all. Then
Sir,
thank you. Thank you.
Sir, excuse me, 1 minute, sir. I have an announcement.
Yes.
Dear participants, the next session will be started by evening, today evening 5 p.m. to 6:30 p.m. Day 1, session 2 of FDP is on the topic CAD and additive manufacturing, delivered by Dr. V. Saravanan, software architect, Siemens PLM Software, Pune. Kindly join at least 15 minutes earlier for the session so that we can start sharply by 5 p.m. With us, stay safe. Suneka signing off from MO in the evening. Over to the organizers.
Madam, excuse me.
Yes, sir.
Madam, one participant raised his hand.
Okay,
So,
okay, sir.
This odd on Suresh G. Sir, please mute your audio and yeah. Okay, we can wind.
Okay, sir.
Thank you.
Thank you, sir. Thank you.
Thank you, Gopalakrishnan sir. Once again, thank you so much. We will meet in our campus after long. We will meet in our campus, and I hope you are in Satyamangalam now.
Yes, sir.
Okay.
We will meet after the lockdown.
Very thanks. Very meet with you through virtual mode.